In this section or chapter, we'll talk about the sampling distribution of our mean. Okay, so we'll start by talking about what sampling variability means. Okay, so you have populations and samples. And we mentioned this before. So again, our population refers to all of our individuals or events that we're interested in. But usually it's going to be too difficult or too time-consuming or expensive to collect data on an entire population. So we look at a smaller subset called our sample. And we assume that our sample be representative of our population. And if it is, then our sample can be used to make inferences about our population. So a parameter is a number that describes a characteristic of our population. So we want to know the value of the parameter, but that's impossible without actually having data on our entire population. A statistic describes some characteristic of our sample, and we'll use that to make inferences about our parameter. So once we take a sample, we know the value of our statistic, but that value would change based on which sample we pick. We call this statistical inference because we use the sample data to infer conclusions about the population. So let's say we want to estimate the mean height of all the USU students. So our population would be all USU students. The parameter would be mu, or our population mean height. What would be a possible sample? This isn't a right or wrong answer. There are many choices that we could use, but we could pick maybe 100 random students. Okay. And what sample statistic could we use to estimate our population parameter? Which is a lot more complicated sounding than it needs to be. If we want to estimate our population mean, we'll use our sample mean. So x bar always represents our sample mean, and mu represents our population mean. Okay. If we wanted to estimate, say, our population standard deviation, what could we use? Well, we would use S, or our sample standard deviation, to estimate sigma, which is our population standard deviation. So that makes sense, right? Like we'd use our sample mean height to estimate our population mean height, or we'd use our sample standard deviation to estimate our population standard deviation, things like that. We do have specific notation for population versus our sample. So population parameters would be like our mean for mu, standard deviation, sigma, variance sigma squared, and size. I don't think I've ever actually seen anyone use this capital N for our population size, probably because we usually don't actually know our population size, but it is there. Our sample statistics then, like our sample mean would be x bar, our standard deviation would be S, and our sample variance would be S squared, and our sample size is N.